Hi students, in this video we will be solving question number 9 from the chapter Straight Lines and the exercise 10.1. If you go to playlist and look for straight lines, in that folder you will be able to find all the sums and derivations related to this chapter. Now let us check question number 9. Without using the distance formula, show that the points, 4 points are given here. We have to show that these 4 points are vertices of a parallelogram. So to begin with, we are going to name these points as A, B and C, D respectively. Okay, now let us draw a parallelogram and mark the vertices. I am calling this minus 2 comma minus 1 as A and 4 comma 0 as B and 3 comma 3 as C and minus 3 comma 2 as point D or the vertex D. There is a very important property of a parallelogram that we are going to use here. What is that? Opposite sides of a parallelogram will be parallel to each other. That is, AB and CD are opposite sides. They will be parallel to each other. AD and BC are opposite sides. They will be parallel to each other. So that is what we are going to prove now. We are not using distance formula and finding the distance of AB, BC, CD and all. We are writing the property of a parallelogram here. AB parallel to DC and AD parallel to BC. This is what we are going to prove now. When we started with straight lines chapter, we learned a very important property on slope of a line. What is that? Whenever two lines are parallel to each other, their slopes will be same, correct? If the slopes are same, then the lines are parallel. When the slopes are same, the lines will be parallel. Vice versa, correct? Lines are parallel, that means slopes will be same. Slopes are same, lines will be parallel. So we are using that property. Why is that so? If you just consider AD and BC and consider this as x-axis. Now look at the angle of inclination. The angle of inclination with positive direction of x-axis in anti-clockwise will be same. That angle of inclination and tan of that angle of inclination is this slope. That is, if you consider that angle of inclination as theta, tan theta is the slope of the line. If theta is same, then tan theta will also be same. Correct? That is why when two lines are parallel to each other, their slopes will be equal. So we are using this concept and we will be solving this sum. When we know 2 points on a straight line, how do we find the slope of a line? It is y2 minus y1 by x2 minus x1, right? Yes, that is what we are going to do now. And first we will consider the slope of AB. We are considering A and B. I am considering this as x1, y1 and this as x2, y2. So in the numerator, for y2 minus y1, what are we going to write? 0 plus 1 because minus of minus 1. So it is 1 in the numerator. In the denominator, x2 minus x1 will be 4 plus 2. 4 minus of minus 2. So that will be 6. Slope of AB will be 1 by 6. Now, if we calculate slope of DC, then that also should come as 1 by 6. So let us calculate now. Slope of DC is equal to, now this is x1, y1, this is x2, y2. This x1, y1 and x2, y2 can be interchanged. It doesn't affect the slope. So this is y2 minus y1. So 3 minus 2 is 1. 3 plus 3 is this denominator, that is x2 minus x1. So again we got the slope as 1 by 6. So what can we say? Slope of AB is equal to slope of DC. That means AB is parallel to DC. That is, side AB is parallel to side DC. Half of the thing we have proved now. The remaining half, that is, we have to show that AD is parallel to BC. For AD, I am considering these 2 points. For BC, I'll be considering these 2 points. Again, for AD, I'm considering this as x1, y1 and this as x2, y2. To find the slope of AD, y2 minus y1 will be 3 plus 1. 3 in the numerator, correct? Then this will be minus 3 plus 2, which will be minus 1. So what do you get your slope of AD as? That is minus 3. Now we'll find the slope of BC. That would be this as x1, y1 and this as x2, y2. So it is 4 comma 0, 3 comma 3. So slope of BC will be 3 minus 0 by 3 minus 4, which will be minus 3 again. So what can we say? Slope of AD is equal to slope of BC. That implies side AD is parallel to side BC. So we have just proved that AB is parallel to DC, AD is parallel to BC. By this, we can conclude that the 4 points, the 4 given points are vertices of a parallelogram, and we have not used the distance formula. Without using distance formula, we have proved this. If you have any doubt, please do mention it in the comment section.